is Megan, and today I'm going to talk to you about our FlexiForce pressure sensor project with Ben Nato and Chris Hashem. The objectives of this project, there were a few of them. First and foremost was to educate and help our peers to complete their project on time. Then we had to convert the output of an analog sensor into a digital input that can be read on a computer. We also needed to light an LED with either an analog or digital output channel on our microprocessor, and we had to calibrate our sensor in order to obtain a visual output using a light-emitting diode. For our process, we first needed to choose a sensor, an analog sensor. Then we needed to figure out how we were going to do our analog to digital conversion. We also needed to obtain an LED. Then we have our LCD screen readout, and finally our computer readout. So for our sensor, we chose to use the FlexiForce pressure sensor. The sensor acts as a variable resistance. It's about 7 3/4 inches long and 8 thousandths of an inch thick, and it can measure up to 800 pounds of load. The way it works is there are two silver conductors separated by pressure-sensitive ink. And when there's no pressure, the ink acts as an infinite resistance, so no current can flow through. And as pressure is applied, the ink separates, allowing current to flow through, and the pressure applied to the sensor is inversely proportional to the resistance output by the sensor. And now to talk to you about our analog to digital converter is Chris Hashem.
This is our AV converter. We use the Arduino Mega. It can connect to the computer via USB cable. It also has a port for a DC power supply. It has analog input pins as well as digital output pins so that it can go to the computer and read from something like our sensor. It outputs a digital signal to the computer which can be then read onto our LCD screen. These are the pinouts for the Arduino Mega. They're kind of hard to see right now, but everything's posted on the blog, so you'll be able to go over them in full detail later on. And this was our original schematic. Here you see a 5-volt source which comes from the Arduino itself, goes into the FlexiForce sensor, which is a variable resistance. Right after the FlexiForce sensor we have a probe pin going to analog pin 0 on the Arduino, and we have a resistor after the analog pin for a voltage divider. In our original circuit we just put a lot of resistors together, so we don't actually know what the value of that was, but it wasn't enough at the time. Now we have a set resistance that is great enough for our purposes. And this is our original program. Everything's commented, so you'll be able to go over it in detail on the blog. But on the first few lines we have our definitions and declarations. The first one selects the input pin on the Arduino that the sensor is going to go to. And then the second is integer val equals 0, which sets the actual reading integer. And then here it sets the speed at which it takes reading, which is 300 bits per second. And then this loop down here, it just basically reads, prints the value, and then waits, and then loops over and over again. And for the LCD screen, it's Ben Nato.
With the way we have our new circuit set up, we integrated an LCD screen along with 10 LEDs to make the data more visible to the user. The LCD screen uses a basic 2x16 LCD screen, which means it has 2 rows and 16 characters per row that it can print. And as you can see in our schematic, we have it wired in with 4 digital output pins that take the reading from the Arduino and print it right onto the screen. Also up here we have 10 LEDs attached to 10 digital pins that light up one for every 10 pounds that is applied to our FlexiForce sensor. Our FlexiForce sensor is down here. We have 5 volts going through it, and we have a voltage divider that is read through analog pin 0, and the Arduino converts that reading into bits, and from that we convert that into pounds, and it is printed onto our LCD screen as well as on the computer. In order to calibrate this, as you can see, since the Arduino reads it as bits, we had to convert it back into volts because the equation we got from the TechScan website changes the voltage into pounds. So we need to get that voltage. We just did that by dividing by 1024 bits because that is how many bits the Arduino reads. Multiplies by 5 volts because that's the voltage we had going through it. and multiply that 24.24 because that is the equation we got from the website. And that gave us our pounds. Also, we needed to get it so the LEDs turned on every 10 pounds, and we did that just dividing the 1024, but dividing the input bits that we got from the Arduino by 1024, and that allowed it to light up every 10 pounds. Here's the basic programming that we had for our circuit. As you can see up here, we defined the sensor pin as A0, which is the input from the FlexiForce. We called the library for LCD displays because Arduino already has a library set up for that. This makes it easier to program. We set the pins that we were going to use for the LCD screen, and here we declared our variables. As you can see, we used float instead of integer variables because we needed more decimal places. When we used integer variables, things were being rounded prior to we needed them to be, so our final values were incorrect. Here we set the pins for our LEDs and the amount of LEDs we have. In the basic programming here, we set the LCD to print weight in pounds on the first row, and on the second row, as you can see over here, we have it print the actual pound number. So above it, it just says weight in pounds and then how many it actually is. Also, we have the LEDs lighting up every 10 pounds, and that is just a basic array that we set up into the programming. Up here we have all our conversions that convert the analog reading from the sensor into voltage and then into pounds itself to then be printed onto the LCD screen. And that is our basic programming. You can see in more detail on our blog. It is posted there. And here are the resources and references we use for this. As you can see, the Arduino website, it has a great forum and a lot of sample coding that you can look at to help you understand more. TechScan website has a lot of information about the FlexiForce, and that's where we got a lot of things in the data sheet for the FlexiForce. Also, SparkFun.com has a lot of data sheets, and that is where we bought the majority of our hardware here, and we got a lot of our data sheets from that website. myweb.wit.edu, Johnson T, that's Tim Johnson's website. When we were originally doing this project, we were using the MSP430. That is where we got a lot of information on that. Unfortunately, we abandoned the MSP430 and came to the Arduino because it was much easier to use. And Zach Barron helped us out a lot with our initial programming, initial issues we had at the very beginning of our project. And thank you very much, and now we will show you our circuit up close and give you a demonstration of it.
So this is our circuit. As you can see, we've got our FlexiForce sensor right here, and it's connected to the Arduino, which is right here. We have our 10 LEDs right here, and they connect to the digital pins in the Arduino over here. And they light up in sequence starting from here, and as you apply more pressure, this one, then this one, then this one will light up. We've also got our LCD screen right here, which outputs our weight in pounds into words, so you can actually see a number for how much load is being applied.
So here's the Arduino software that we use to upload our coding onto the board. As you can see here, we have all our coding, which can be seen in more detail on the blog. Up here are all your menus. This button here verifies the coding to make sure there's no errors. And this button here uploads the coding onto the Arduino board itself, so the Arduino knows what to do. Prior to doing that, make sure you go to your Tools menu and make sure that your correct board is selected. We have the Arduino Mega 2560, so that's one we have selected. And the serial port that we're connected to is COM7, so make sure you have the correct port or else it will not upload properly. Also up here is the serial monitor, which when you click that, it pulls out this box here that is giving all the readings from our sensor. And as you can see right now, it's giving a reading of 0 because there's no force applied to our sensor. Now if we go over here to our actual circuit setup, you can see on our window here, our LCD screen here, that it is also reading 0 because there's no force applied. When we apply a force to our FlexiForce, you can see that that number changes as well as this number here on the program. Now, you do not need, after the program is uploaded to the Arduino board, you do not need it connected to a computer. You can have it run separately if you plug it to a DC power supply. And the way that works is this chip here is already pre-programmed with the program that you have it set so it can run independently. And if there's ever an error, you don't need a computer. You can just click this button here, which just resets the whole circuit, and it'll bring it back to its original coding. Here you can see we have our 10 LEDs lined up, and what those do is every time the weight hits 10 pounds, and every 10 pounds after that, another LED will light up. And we have 10 here, so it can go all the way up to 100 pounds. And that is how our sensor works. Thank you very much.